Hello guys, welcome back to our channel Career at Market Value. So the topic of today's discussion will be estimating value at risk through PARCH, assuming a student's T distribution. So last week guys, if you remember, we did estimation of value at risk through PARCH, assuming a normal distribution. So today our focus will be on student's T. So it's a similar way. Firstly, we have to calculate the long run variance, which is almost the same. So in the same fashion, we'll continue. We have taken the long run variance. Let's paste the format as well. Then standard deviation will simply be square root of the variance. There you go. So we'll move into eViews for the next set of estimations. So let's open the eViews panel. This is the panel. Okay, so we'll go to quick, then estimate equation, then we'll write our equation over here. Sorry, this should be small, space C, and we'll change our date guys, since we will be estimating 70% of our data. So our date would simply be 11th of November 2010, since our 70% of data is still this date. So 11th of November 2010. Okay, so now we'll go to Arch, we'll change it to PARCH, and error distribution should be students T, and Arch1 and Garch1, the one should be remain as it is, since we are estimating PARCH11, so this should be as it is. So we'll click on OK. So we got our equation and everything. So let's first of all copy our degrees of freedom, just this. So let's keep this over here, take the degrees of freedom. So this is our degrees of freedom. Then we have coefficients from C2 till C6. So C2, C3, C4, C5 and C6. Guys, there you go. Now you will simply need to copy the coefficients. This one, C2, then C3, then C4, then C5, and last one is C6. Okay, there you go. So after this, we will simply copy the equation, which is this. Okay, so we got our equation. So first of all, for the simpler terms, I mean for the long run variance and the standard deviation, which we have calculated without applying the equation, we will estimate our value at risk for them. So first of all, we need to copy this degrees of freedom, since this will be required. So for students T distribution, we will be applying T inverse, right? So T inverse is applied. Now it is asking for probability, and this is this column is for a 95% of confidence interval. So we'll apply 5% significance and degrees of freedom, which we have already copied. We'll close brackets, apply minus sign over here, we'll again close brackets and multiply this by standard deviation. So there you go. Now we'll simply copy this. For our 97.5, this thing will be 2.5% significance level. For our 99%, this thing will simply be 1% of the confidence interval, significance level, sorry. And for our 99.5, this will be 0.5. There you go. So the next thing we will be applying our equation. So the equation simply states square root of GARCH to the power of 6. So this is this, guys. We'll paste this over here. So it says square root of GARCH to the power of C6. So square root of GARCH or square root of variance is simply standard deviation. So standard deviation to the power of C6. So C6 over here, guys, is this value. So we'll copy this. First of all, we'll change the symbol over here, standard deviation to the power of this value, which is C6, right? Now we will estimate it. It starts from C2. So C2 is this. Okay. Place an equal to sign over here. Then plus C3 plus of C3 let me put this in brackets, plus of C3 multiplied by absolute, then our residual to the point t minus 1. So our t minus 1 residual is this one. Since this is the return, so this is the residual, right? Okay. So now it says, now I will close the brackets for the conjugate, another one to close. Okay. So the next it says minus of C4. So C4 is this one. Copy this. So minus close brackets, open brackets, then my value, then multiply this by residual n minus 1. So guys, as I have as you could recall in the previous example of PARCH normal as well, we need to take this value in absolute terms. Since negative power of the negative value, Excel will give a num error. So hence I'll open another bracket and put an minus sign, then I'll open another bracket and write ABS. I'll keep this as absolute. Then our residual n minus 1, which is D3278, you can see from here the value of our residual. Then I'll close brackets, then it says to the power of C6. So to the power of C6, C6 is simply 1.140603. So 1.140603. There you go. Now I will close all the brackets. There you go. Now the equation says plus of C5. C5 is this value. I will copy this. So plus open brackets C5 multiplied by residual n minus 1, which is simply D3278, right? I'll close the brackets and then it says to the power of C6. C6 is simply 1.140603. Okay. So I'll close my brackets and there you go. So okay, there must be some issue with this. plus of my okay, so plus of C5, which is this, okay, then multiplied by square root of GARCH n minus 1. Okay, so square root of GARCH n minus 1 is simply the standard deviation, which is this value, right? Square root of standard deviation, we got that, then to the power of C6. So C6 is this value. So now this should probably work. Yeah. So there you go, guys. Now I'll convert this into percentage. So this is the percentage, and the variance. So now the value that we got, guys, is simply standard deviation to the power of 1.140603. So to convert this to variance or standard deviation to the power of 2 or standard deviation square, we would simply need to do this 2 by 1.140603. So you will get your variance. So I'll convert this into percentage. Okay, now you can simply copy the standard deviation and all the value at risk variables and drag this down. I'll change the format, and you can copy this and drag all these conjugate down. There you go. So our estimation of value at risk through PARCH 1.1, assuming students tree distribution, is now complete. Now I'll simply delete all the equations, this thing, as well as all this. There is something written over here. I'll delete this as well. Now I'll go to the top. So once again, guys, I think at the top this value of the coefficient, which is standard deviation to the power of, is not written, so I've written it now. So now it's complete. So now you guys know how to calculate PARCH for the value at risk assuming a student's tree distribution. So in the next video, I suppose I'll be working on another heteroscedastic equation for estimating value at risk. So stay tuned for that video, and do subscribe, share, and like our content and channel if you like our videos, and do comment down below. Thanks, guys.